Singularity.
My name is Nicola, aka Socrates, and you're watching Singularity One-on-One. If you guys enjoy this show, you can help me make it better in a number of ways. You can click the like button on YouTube, you can leave a comment on singularityweblog.com, you can write a review on iTunes, or you can simply make a donation. As always, I will be the man with the questions, and today the person with the answers is a man who is trying to slow down our path to the singularity. Dr. Roman Yampolskiy has already been once on my show before, and we had lots of fun. I recommend everyone go and watch that interview before they watch this one, because this one is the second interview and it will be the continuation of our conversation from the previous time. Dr. Yampolskiy is an assistant professor at the School of Engineering. Not anymore?
I got promoted, I'm associate, I'm tenured, things are good.
Oh, that's fantastic. So tell us about your position then. What is it now, formally speaking?
So it is an associate professor, I'm also director of our cybersecurity lab.
At the University of Louisville. Congratulations. So things are looking good for you. At the individual level, let's see how they're going to turn out at the humanity level, which is the topic of our discussion. Dr. Yampolskiy is also an alumnus of Singularity University, GSP 2012, a visiting fellow of the Machine Intelligence Research Institute, and an author of a fantastic recent book titled Artificial Superintelligence, a Futuristic Approach. So thank you for taking time to be with us, Roman.
My pleasure. I love doing interviews with you. So far, it's my best experience after dozens of different interviews.
Wow, thank you very much. I appreciate that. I hope we sustain that experience today, and maybe hopefully even build up on it a little bit. So, Roman, I introduced you as somebody who is trying to slow down our path to the singularity in your own admission from our past interview. So let me begin with this. Are you succeeding? It's been a couple of years since our past conversation. So do you feel you're succeeding?
I don't know if it's just me. There seems to be now a movement which is in some ways trying to accomplish similar things. And whatever success we're having, I can't claim credit for most of it. But it seems like there is now at least acceptance that there is possibility of software being dangerous. And so whatever principles we use when we talk about genetic modification, we talk about, human cloning, let's not just see what happens when you clone a human and will it suffer or not. The same concepts are now acceptable in this AI software domain. So I say there is some success. It's not universal. There are definitely people who don't accept concerns, but I think we're doing well.
When you're saying that there's a whole movement, are you referring perhaps to the recent variety of headlines from people such as Elon Musk, Stephen Hawking, Bill Gates, Steve Wozniak, and many others?
Yes, it's actually very
Max Tegmark.
funny or not, but I've been saying it for years as a computer scientist, AI researcher, cybersecurity expert, and nobody paid any attention. But now you have a physicist, you have a business person say the same thing, and everyone agrees with it. It's awesome.
Well, that's the reality of life, my friend. Yeah, so we don't have to be an expert in something so that people actually listen to us, as long as they like, love, and trust us for other reasons, then they would listen to us on anything. It's like it always blows my mind. For example, in Canada, we have one of our prophets. I mean, in Canada, the religion is hockey. So one of our prophets is called Wayne Gretzky. So he goes on TV often extorting the virtues of a particular cereal or something of that sort. And it always blows my mind how you would take this hockey god and you would take his, nutritional advice about cereal, which is probably actually quite full of sugar and not so healthy for you. But yet we seem to do it.
But this time, this worked out really well for my goals, so I'm not complaining. I'm just kind of pointing out the humor in the situation.
Yes, that's inescapable. So, Roman, tell us a little bit about your latest book.
Okay, so it's been a long-term project. I started it around the time of our previous interview a couple years ago with a crowdfunding campaign. It was supposed to be a self-published book, a quick, put it together and ship it out. Things turned out to be a little more difficult. First of all, the crowdfunding campaign didn't generate as much revenue as I was hoping, so I had to take some time. I actually found a publisher for the book, so it's not a self-published book. But just this week, I finally delivered all the perks to people who graciously funded my research. So I'm very happy about that.
That's fantastic. And let me just say, you know, crowdsource fundraising campaigns are very tough and sometimes just lucky in many ways. So, but they're in general not easy to organize. They take lots of experience. They take expertise, just like anything else. And so don't take it like as a bad sign, as you didn't, because you did keep on doing what you're trying to
Correct.
do
I
and you
would do it
accomplished it.
regardless. The money was just there to kind of show interest, judge that. Somebody tweeted, I found it to be very funny, that they had a campaign for making potato salad or something and it generated $30,000. And somebody tweeted, potato salad, yes, super intelligence, not so much.
Yeah, yeah. Actually, I think it was like more like 50,000 potato
Well,
salad, but
a
it's like,
ridiculous amount for potato
yes,
salad.
yes, yes. I totally agree. So those things go viral. They have a mind of their own. They have an fundraising campaigns have an intelligence of their own. So, you said that you actually found, because that was one of the topics we discussed in the previous interviews, whether it would end up being a standard academic publication or an independent publication by you. So you did say that you found a publisher, but does that mean it's an academic publication then?
I would say so. And nowadays, it's an acceptable topic and it's a hot topic. Bostrom's book on superintelligence is number one bestseller in AI. So definitely there is a huge shift, especially in the last year, and what is acceptable, what is even hot. Right now, everyone's jumping on this, trying to get grants, trying to secure some sort of, standing in that field. There is, I don't know, if it used to be one organization working on it, now there is 10 and they growing like mushrooms. Everyone's starting a existential risk center or something like that. So
Wow, that's real good. You know, I'm happy to hear that. I hope it translates also in some benefit for my blog and the growth in my audience. And I have to say, I have noticed definitely a trend of improvement. I haven't noticed it to be as fast as I'm hoping it would become, but you know, that maybe I'm just too partial to it and I want it to be even faster than it is. So
right.
okay, yeah, because and the reason why I asked you that previous question is because I have to say I really enjoyed your book. I think it's very comprehensive, it's very detailed, it's very specific, it's very scientific. One thing it is not, though, it's not too easy to read in the sense that you have so many references, which is the proper scientific academic way to do, but they kind of break the rhythm of reading. And that's a little bit kind of annoying.
I agree completely, and it's also partially a problem with how citations are done in a book. Usually, computer science approach is just to have a series of numbers, 17 through 30. Those are the references. The way it's done by the publisher, they list last names and years for everyone, so it becomes unpleasant. I agree completely. There is not much I could do about it, but it's a great reference book. If you want to learn more about any of those concepts, no excuses. You can find exactly where the information is coming from.
I agree, and you have referred a very broad and wide variety of literature for your book, which speaks volumes about the amount and quality of the research that you have done. So let's just jump right into the meat of the matter here. So tell me, what's the goal? First of all, what's your thesis in your book? What's your major thesis, if there is such thing?
Sure. So the main idea, of course, is that as we spoke in our first interview, every technology has a positive and a negative aspect to it. It could be used for good and bad, and a lot of people always saw AI as pure good. It was
Ah,
tools for automating things, making our lives easier.
utopia.
It could do no harm unless it's a Hollywood movie. Now we're starting to realize, well, no, actually, there is a very solid possibility there could be negative consequences, and depending on what exactly we are designing, they could be more significant than the positives. And I think that's the main point, to make everyone from AI researchers to just lay people realize software could be as dangerous as somebody said nuclear weapons. I don't know if it's exactly that bad, but definitely as bad as a biological experiment gone wrong or something like that.
Yeah, so the stakes are very high. So what in that realm are you trying to accomplish with your book?
So I'm hoping to formalize this as a computer science subfield. Right now, a lot of people we kind of mentioned are not computer scientists who are working this. This is not a huge problem. They bring attention, they bring funding, but they have a very different approach. If you have a philosopher discussing those issues, they see the big picture, but they don't concentrate as much on formalizing the problem, creating protocols, algorithms for actually solving it. You need computer scientists to participate in this. And I think that's one of the things I'm trying to say in the book.
Yes, and you do that for sure. So before we go through sort of the variety of interesting ideas and terms that you define and you discuss in the book, I want to just ask you about sort of an interesting side reference, if you will. So in the preface, you say that Deep Blue defeated Gary Kasparov perhaps due to a bug. Can you perhaps elaborate on that a little bit? What's the bug?
I think at some point it kind of randomized its move without realizing what the proper strategy was. So it was not an optimal strategy to take at this point. So maybe a better program would not discover that line of attack.
Yeah, because I remember watching the game and I remember there was that specific move where Kasparov claimed that perhaps a human have helped the machine make that move because it just totally sits outside of the box of everything that the machine had done previously up until that moment, about the way it conceives of the positioning and the development of the game and so on. And there was lots of debate back and forth about what happened with that specific move. But what I'm trying to get clear is how do we know that was a bug and just not the machine just doing its thing?
Well, we never know, and in fact, right now it's a valid area of research.
Exactly.
One of my former professors at University at Buffalo has a very interesting research project on telling whatever a specific chess move is generated by humans or computers. There is a lot of controversy in chess. People sneak out to bathrooms, use cell phones to get latest update, and then
Yeah.
try to win championships. So they showed they can actually do that. They can tell if something is a typical human move for that player or if it's more like a computer move, which should not be a part of that tournament. So
Yeah.
it seems like it's possible to at least statistically hint at whatever it's assisted by a person or not.
That's a fascinating sort of way of investigation. But the reason why I ask this question is because in some cases, at least, the bugs can be turn out to be the features.
Absolutely, it happens. That's how evolution works, basically. You have a mutation and then you realize it's an awesome one. So, problem is, when you're talking about safety and guarantees, you don't want to rely on side effects of your poor programming as a feature.
Yes, and we're going to go a little bit more into that as we proceed. So let's start with sort of the structure of your book. You have the book divided into 10 different chapters. So I'm kind of going to go not in a perfect chronological order, but sort of through the main ideas as we proceed. So bear with me here for a second. So perhaps we should start with the idea of intellectology. What is it? What does it stand for? How do you define it? And why is it something important and useful to us?
So I think that comes from a chapter which deals with mind designs, trying to understand that human intellect is not the only type of intelligence we're likely to deal with in the future. Yeah, we know about animal intelligence, slightly different than ours, but it's important to understand just how huge the space of possible mind designs is. Depending on how we develop our AI, if it's evolved, if it's an upload from human brain, if it's specifically designed, we can end up with something completely different from what we expect or can understand in many ways. So once you have this science of different minds, things kind of fall into place. You now have development of artificial intelligence as one small sub area. We also can talk about measuring intelligence, comparing intelligence. We can talk about questions such as if you have mind transferred to a different substrate, how do you determine if it's an accurate transfer? Are there tests to tell if it's the same mind after upload or not? So all that kind of falls into something related, but I couldn't find a good word for defining what this new field is. So that was my attempt to kind of again formalize what we're studying and what we would like to see happen in the future.
Okay, so then going beyond the term itself, are you trying to have a quantitative scientific measure for intelligence that is transferable via transferable over time, space, and perhaps stratum, so that you can perhaps compare the intelligence of one machine versus another machine versus a human being, and so on?
I definitely see intelligence as a fundamental computational resource. So we usually talk about space, time, and randomness as the three resources used in generating algorithms with different capabilities. I think intelligence needs to join that as another such resource, and I think the laws of physics would apply to it as well. And one of the more interesting kind of guesses I have is that if we look at extremes of intelligence, we'll get new types of observations, just like we do with speed, for example. At extreme speeds, things are very different. At large scales, tiny scales, things are not the same as they are in our typical world. We used to IQs of 100, 200. We have no idea how it changes when you have IQ of 1,000. My guess is it's not a linear extrapolation.
So your guess is it's not a linear extrapolation, but your guess is that it can be extrapolated, that it can be quantified, and it can be assigned a specific and accurate measure, which can then be used for comparison purposes, etc.
I think so. And I try to talk a lot about are there maximums to intelligence, are there minimums to self-sustained recursive improvement process. So those are the interesting questions I think the new field of intellectology will address.
And let me just give you a quote here. At the end of that chapter on page 35, you conclude by saying the following: I believe that intellectology will highlight the inhumanity of most possible minds and the dangers associated with such minds.
Right. So if we have this huge space of possible designs, this big, and human intellect is a tiny dot in it, and anything around it, animals, maybe biological aliens, are similar enough to where we can at least understand, okay, they want food, they want companionship, anything. Anything outside of that tiny circle is so different, we cannot even understand what we're dealing with. We cannot predict their goals, desires. It's not something we encountered before, but mathematically we understand the difference between, a range of few integers versus infinity. It's not just they like different food. It's a much bigger difference in everything.
Mm-hmm. And so you're saying that the danger lies in the gap, actually.
The danger is us failing to predict how such systems would achieve their goals
Because of the gap difference between
because
us
of the
and
gap.
them.
We have no way of even estimating what it would be like. It's also different moral and ethical structure completely. Things we don't have universal morals and ethics, but there are some things we kind of, as biological entities, sort of agree on. That default would no longer exist.
Yeah, which again, of course, is because of that gap of difference, right? So, yeah. So let me then perhaps roll the tape a little bit and go a little bit more towards the beginning of the book and touch on another issue here, which is AI completeness. Mm-hmm. What do you mean when you refer to something as being AI complete?
So this is by analogy to MP completeness. We discovered that certain problems are also the most interesting and the most difficult problems known to science. They also happen to be deeply related. Even if the phrasing is very different, they are transferable. If you can solve this one, the answer would work for all the other problems in that field. AI completeness is that type of problems, but related to AI. The hardest problems in AI. So if we solved something like playing chess, we know how to do it. It's not an AI complete problem. We cannot reduce every other problem like computer vision to chess. Whereas there are problems which are fundamental. If you can do it, you're done. So in my book, I show that passing Turing test is such a problem. If you can answer any question, as well as a human, you are definitely a human level intelligence. And then we can reduce our problems to an instance of Turing test. We can encode those sub-problems as part of a Turing test. Describe this picture to me, for example. So it's very important way to formalize what is this notion of superintelligent machines, human level intelligence. What can they do? How do we know if we succeeded? If we have a system capable of solving AI complete problems, we got human level intelligence.
Mm-hmm. So let me ask you, for example, is the problem of computer vision AI complete or not, and why?
It is AI complete, as I presented, because we can encode anything in terms of your visual recognition patterns. So there are certain things we are starting to be good at. We recognize faces, some objects, but I can really present anything in your field of vision, and any type of other problem can be encoded as such. Mm-hmm. It could be multidimensional, it could be two-dimensional, but at the end, really anything you want to challenge someone with can be visually encoded. It's not something we see in our everyday experience, but there is a scientific formal way of accomplishing that.
I see. Very interesting. So, moving on here towards, I just want to touch base with all the major ideas of your book if we can, and this way sort of stimulate our audience to perhaps jump into it a little bit deeper, because obviously you're very specific, very scientific, and go very much into the details of those things, and I can't afford to do that in the sort of the medium of this interview. But if I touch on the major one, I'm hoping we're going to spark their interest and encourage them to check it out and learn for themselves. So another very interesting term is what you refer to as the singularity paradox. Tell us a little bit about that.
So we talk about machines becoming super intelligent. Then we say that word, the assumption is they are better than us in pretty much everything, they are smarter than us. But the fear is that because they are not like us, they actually don't have our common sense. Yeah. Human common sense, something a 10-year-old would have. So the paradox is you have this super intelligent system which doesn't understand the simplest of things. It seems like it's a paradox, at least in naming. So
they're too smart for Jeopardy, chess, cancer diagnosis, but they're yet too dumb for just common sense stuff that a 6 or 7-year-old kid can distinguish.
Exactly. That's exactly what it is.
And is that where the danger lies, perhaps?
Yes, because then you order such a system around. It understands the final goal. It understands you want the final goal to happen, but it has no common sense to understand how do you want to get there. So if I tell the system, make sure there is no people with cancer, there are multiple ways to get there. You can cure cancer or you can kill everyone with cancer. If you don't have common sense, I mean, why is one better to the other?
Mm-hmm. Well, let me ask you this then, though. If we presume that intelligence doesn't have common sense, then wouldn't that by definition make it narrow artificial intelligence rather than general and or super intelligence? Because, I mean, how super or general is that intelligence if it doesn't even have common sense? It will be only narrowly intelligent.
The problem is common sense is not formalized or well defined. Just because I don't think it's a good solution, I didn't explicitly tell you, no, I want you to cure cancer. I was not specific. As programmers, we see it all the time. I want my program to do something, but then I start programming, I tell it to do something else, and it does exactly what I say. It tries to do it as efficiently as possible. But if I misstate what I'm trying to accomplish, it would not work.
Yeah, I'm trying to remember which one of the Platonic dialogues it was. It's very famous about one lady who was a daughter of Zeus who asked Zeus to grant her husband eternal life, which Zeus generously did. But what he failed to do is to give him also youth. And so that person kept getting older and older and more decrepit, and yet they would not die.
Right.
So it was not a blessing, but it was a curse in the end because she was not clear enough, and or Zeus was sort of evilly joking with her request of eternal life.
Right. And of course, it depends on, is the system really trying to do the best for the wisher, or if it's just trying to accomplish something with least amount of effort.
Yeah, and thereby that sort of empathy or the ability of the system to perceive and evaluate the set problem from the point of view of the programmer is vital, and therefore that gap that we discussed before, it may be a crucial sort of barrier to such an understanding, because if you have such a huge gap, then it may be almost impossible for them to understand us. Even though I can see how it's more logical to say that we would definitely not be able to understand them, but perhaps I'm thinking they might be able to come down to our level, or would they?
It's possible that they can. It's definitely easier to go to a simpler system than to go the other way. We don't have enough memory, enough different states to fully comprehend a bigger mind in terms of its complexity.
Yeah, by the way, we have sort of the Toronto Air Show today, which you may hear the jets are flying by my building. I'm on the 18th floor, and so they're like, a few hundred meters away from me. So you may hear the jets flying every once in a while, for
Must be
which
a
I
nice view.
apologize. Yeah, it's very nice. Okay, so put simply, the singularity paradox is that they're too smart for almost anything, but yet they're somehow too dumb for common sense.
You got it.
All right. The next thing that you discuss in the following chapter, I think it's wireheading.
Mm-hmm.
So tell us what wireheading is and why is it a problem?
So the term comes from psychology, I believe. In 70s, they did some experiments where if they stimulated a certain part of the brain directly, it produced very pleasurable response, kind of orgasmic feeling, sustained feeling, which didn't become lesser with time. And they did experiments in rats. They allowed rats to self-stimulate that region, and they quickly became super addicted. They wouldn't eat, they wouldn't be interested in sex partners. All they wanted to do is press the thing. They would walk over electrified floor, anything to do that. There are similar experiments with human brains showing very similar results, and we see it in people addicted to hardcore drugs as well. It seems like any system, whatever, natural or artificial, if it has this reward channel, would at some point realize, well, I can try hard and earn my award, or I can just hijack the channel and press the button to reward myself.
Mm-hmm.
And that's very dangerous, because if you are the one holding the controller, holding the remote, now the system goes after you, because this is the easiest way to get as much reward as possible.
Mm-hmm. So how can we avoid that, if at all?
That's a great question. So we've been trying as society to control people's addictive behaviors forever. We limit exposure. A lot of those things are illegal. We try to, have rehab centers, but I don't think there is a universal solution to that. This is the thing. No matter what you do, at some point, if we had this direct, easy access, most of us would become wireheads. Problem is, well, not a problem. The good thing is, it's very hard for a human to directly self-stimulate their brain, whereas for a machine, it's just a function you call. It's a much simpler access.
And in the case if it's self-improving or recursive self-improving intelligence, then it might actually do that on its own.
Right, it's exactly what it is. So we suspect it may not be as productive or even willing to do anything to benefit us. It would simply find ways to get control over its reward channel and maximize the reward, which also produces additional side effects. Now, do you need more memory to store additional reward? How extreme does this get?
Hmm. Well, so maybe that's the bad news as you gave the example, but maybe that's the good news as to why they'd want to leave us alone, and just sort of lock their mind into sort of a virtual world of sort of orgasmic or nirvana or something, and just stay there and self-stimulate ad infinitum.
There is no upper limit to pleasure, just like I suspect there is no upper limit to intelligence. So you always want more. You might be doing really well now, but you want to go, well, why don't I add more memory? Why don't I increase this? Have more artificial beings experiencing it? And that's where the safety issue comes in. They might use our planet as a memory storage device. They can convert you into useful bits to store additional pleasure.
Hmm. Very interesting. So you're thinking that that kind of desire for pleasure stimulation is non-satiable.
Um, it doesn't seem to have an upper limit. I mean, so far we haven't encountered any physical constants showing, okay, this is the most pleasure anyone can experience.
Okay, so let's see if and how this problem of wireheading is connected at all to what you describe as the confinement problem.
So anything related to safety is also related to the issue of controlling the system. Before we have a chance to test it, before we know that, okay, maybe it's kind of safe and secure, how do we run experiments on it? You can't just release it on the internet and see what it does. It's like the worst virus possible. So you need to have some sort of confined environment where you can maybe run a portion of it, see what it does, interact with it in some manner. Um, we see it done with computer viruses. You have an air-gapped computer, not connected to anything, you run things on it, you're trying to understand how the virus works, who controls it. This is the same idea, but now you have this intelligence on the inside trying to also find exploits in your system and escape from it.
And so, how unsurmountable or how AI complete is that confinement problem?
So this goes back to standard cybersecurity. The fundamental rule is there is no perfect security. There is always, given enough time, resources, will, stupid social things humans do, the system will have a hole, AI will escape. The question is, does it buy it enough time to kind of do some useful experiments on it? It seems like it's better to have something than nothing, even if it only slows it down a little by a few years, few months. It's still better than just releasing it and seeing what happens.
So, and which is why, of course, you're saying that you don't work on preventing the singularity, but at best on slowing it down.
I don't see a legitimate way of preventing it. Obviously, there is so many competing agents, governments, corporations, individual scientists. We don't know how difficult the problem is. If it turns out that AI is just a single formula, like E equals MC squared or something, and a guy in a basement with a laptop can do it, you can't stop that. If it takes something like Google, trillions of dollars, Manhattan style project, then we might be able to control it a little better, slow it down. But since we don't know, it's unlikely to be controlled, and yeah, it's going to happen. The question is, do we have enough time to make sure it's as safe as it can be?
So Nick Bostrom has done some research on sort of the timeline that experts in the field have estimated to that potential moment. Whereabouts do you stand on that timeline?
So experts are well known for being wrong and predicting future. I kind of agree with what Kurzweil does. He's probably the one who does the most formal scientific estimation of trends, progression of hardware. He equates ability of hardware to human mind, and 2045 is his answer, and I kind of like where that stands.
In other words, we have about maybe 30 years, give or take.
About.
And are you optimistic we'll be ready for it?
I'm realistic. I'm not a pessimist or optimist. I'm hoping that we'll realize what the problem is and we do have enough time to address it properly.
Mm-hmm. Tell us more about what realistic means.
Well, it's important again to look at both sides of an issue. So Kurzweil is someone who's a technology optimist. He only sees positive in it, and I think his solution is that we're going to merge with our technology. We'll start with brain implants, we'll slowly move on into uploads, and under his definition, it works really well, but it feels like we're losing humanity in the process. We'll become programs on a computer with completely different needs, abilities, so we'll be a different species, if you will. We'll be the old Neanderthal kind of fossil which no longer exists, so is valid. So in his world, that's a solution, and he's optimistic. Um, Pessimistic thing is, well, the systems are so dangerous, they don't care for us, they'll destroy the world for sure, we only have a few years left. Realistic is somewhere in between. Yeah, we might have to change, we might have to slow down how much we rely on this technology, but there is a non-zero chance that things will be good.
Very interesting. So I think this may be the moment that I will throw in some ethics into the mixture. So now, in your book, and last time in our conversation, you kind of touched a little bit on it, but you say that machine ethics and robot rights are both misguided. Tell us a little more about that.
The problem with just ethics, trying to pick one set of ethical guidelines from what people practice and give it to machines, give it to robots, is that we don't agree on any such set. There are cultural differences, religious differences, so basically you'll end up selecting one of those and enforcing it on everyone else. Not very ethical, nobody's gonna like it, it's a problem. Problem with robot rights is that that immediately comes with civil rights. Now you have voting rights given to software capable of making copies of itself, trillions of copies. That's equivalent to saying, I no longer want to have a vote. Just mathematically, the moment there is trillion voters voting as the same, voting as a block, your opinion doesn't matter anymore.
Mm-hmm.
So it destroys any type of true representative democracy for humanity, and I think most people would be against that.
And even one better, you say that AGI research on page 138 actually of the book, you say that AGI research in general is unethical.
Right.
And so that would mean that people such as Ray Kurzweil, Peter Voss, Ben Giorzo, and a number of others whom I've interviewed on the show who are working on artificial general intelligence will be unethical.
Unethical in the same sense as someone working on human cloning is unethical. I don't think they're bad people. I just think the results of their research, if they're successful, would be very dangerous for us. And in a lot of cases, the good thing is the problem is so difficult, they are unlikely to succeed. So they might have a very good project, they claim it's AGI, but at the end, they're still designing a stockbroker, trader, software, which is good, but it's not AGI in any true sense. It's not going to switch to any other domain.
Well, Peter Voss, who is one of the people who actually gave the name of the term, in my interview with him, he said there is nothing more important and or exciting than building artificial intelligence. And he also said that having more intelligence will actually be very good for humanity, especially if it's artificial general superintelligence. That's his, and therefore it's unethical to prevent such research.
Intelligence is a tool. It's a way to accomplish your goals. How those goals are selected and how you select the path to the goal is a different issue. That's where the human values and human preferences really make a difference. So you can have a super intelligent system which actually goes against most of our ethics. It can favor strict eugenics. It could favor, exterminating not useful humans. You can definitely show how rationalizing allows you to do those things.
But his answer was that a really smart intelligence wouldn't do that, because I kind of argued with him along those same exact lines, but he was arguing that if it's really smart and intelligence, it would know it's better to keep those humans. And I was trying to say that perhaps there may be some cases in which, logically and rationally speaking, the better, more efficient thing to do is not necessarily the ethical or the right thing to do. And that's precisely where real ethics steps in, right? Doing what is not rationally the most optimal course of action. Because if we have a perfectly rational optimization machine with super intelligence capabilities, then which would have no emotional attachment to us, then I'm kind of like more along your lines here, definitely on this issue. But yet Peter Voss was convinced otherwise.
I think he's right in saying more intelligence is good for humanity. So if all of us had extra 20 IQ points, we'd be better off. But as I said, when you go to extremes of intelligence, it's not a linear extrapolation. Things break down. So think about it this way. Then you update your computer. You go from your 286 to Pentium 5. Do you keep the old 286, tape it to the new machine, and hope that they help each other? No, you throw away the old garbage. There is no reason. It's not contributing anything. It's a bottleneck. That's what human intelligence would be to a system with IQ of 1,000. You cannot contribute anything. The only thing you know is what it's like to be a human, and is that valuable to someone who's not?
Mm-hmm. Interesting. So perhaps now is the moment where I should throw in efficiency theory, because we did touch on sort of the optimization and efficiency of the system. So talk to us a little bit about what you call efficiency theory and how it's relevant to the issues we're discussing.
Okay, so that's a somewhat different chapter from the rest. It's not as much pure AI discussion, it's more the understanding deep computer science concepts. Typically, we as computer scientists like efficient algorithms. We hate brute force more than anything. It's not really computable for anything in real life. But one thing I observe is that
they're not very elegant. I had a number of people tell me that the reason they don't, it's like mathematics. People like the simplistic beauty of E equals mc squared. That's where the genius lies in it. Brute force, being brute force, there's nothing elegant and beautiful about it.
But this is where I disagree. Brute force is the easiest algorithm to explain to anyone. A freshman, first day of classes, will understand this algorithm much better than any more efficient algorithm you will give them. It's also a perfect algorithm. It will give you the best answer, guaranteed. Everything else is heuristics. We're hoping that this is good enough. It's not perfect. It's not beautiful. Given infinite computational resources, you would always go with brute force. That's true thinking. Then you consider every option. Humans are very good at bias, heuristics, and kind of hacking search space and finding those low-hanging fruits. But we don't make optimal decisions. We have over 200 different cognitive biases we are subject to, all heuristics to simplify search. If you look at when AI started making real progress, last couple of years, why is that? We finally have hardware sufficient to support big data, huge computation, really brute forcing a lot of those problems. We take, 10 million documents, we read them, and now all of a sudden we understand those documents. When we were dealing with 10 documents, 100, the same algorithms didn't work. Brute force is fundamentally very powerful and promising, and I think it got a bad rap for many years.
Mm-hmm. Yeah, and yeah, I'm kind of like, I'm trying to figure out where I'm sitting on this one, and I'm kind of like half and half, because I can see the point that both Noam Chomsky and Minsky are making with respect to brute force. They're not denying the importance of brute force. In fact, Chomsky was saying that the best hopes already in the 60s was saying the best hopes of ever accomplishing anything was through brute force. But they're saying that real knowledge comes from having a theory which doesn't sort of intelligence give you some kind of a bias, which is in a way, a bias is always like a shortcut, right? It takes you from point A to point B in the fastest way possible so that you don't have to explore all optional potential alternative routes between those 2 points, right?
Right.
So in that sense, I think I can appreciate what they're saying, but I also appreciate that what you're saying is that after you reach perhaps a certain level of brute force capability, then it becomes irrelevant because it happens so fast and so quickly that it's like irrelevant. You do still end up with the most optimal outcome, even though you consider all the potentialities, supposedly.
Right, and we might switch to a different computing model, quantum computing, where things like that become very easy for real world size problems of inputs. We talked about, you brought up this concept of elegance. To me, then they brute force checkers and showed perfect checkers player. That's beauty, that's knowledge, that's elegance. Then they had heuristics, occupy middle squares. It's all cute, but it's a shortcut which may allow you to get to the destination, but you miss all the beautiful paths to get there.
Hmm. I think, to my mind, a better problem, perhaps, and you correct me if I'm wrong because you're the expert here, is the so-called traveling salesman problem. Is that more of a sort of, because we cannot, or can we really brute force it?
Not for any significant size inputs.
Right.
I'm teaching AI course, and that's the project I just gave them. The first project is to brute force TSP. They all fail, and then we start learning shortcuts.
Exactly. And so that's my understanding. And but my understanding is also, after my conversation with Jordi Rose, is that D-Wave or quantum computers in theory can resolve that very elegantly and efficiently without brute forcing it.
So the chapter is about sort of extremes of what we can do in terms of knowledge, in terms of computation, in terms of understanding, compressing knowledge. It's not a very practical tool yet.
Hmm. Roman, someone would say that, I think it was in our preliminary discussion where you mentioned that, or maybe at the beginning of the interview, you mentioned that Nick Bostrom's book on the topic is like the bestseller in the niche. So someone who is not familiar with your work would want to ask you, how is your book similar and or different from Nick Bostrom's book?
So they are on the same topic. That's the main similarity, but they are very different. Bostrom takes a very slow approach. He gradually introduces the concept. It's wonderful for beginners. In my review, I say, buy his book first. It's definitely the intro to superintelligence. My book is more for advanced readers, someone who has background in issues related to AI safety, to superintelligence. It's more from computer science point of view. So I propose specific algorithms for communicating with AI, define problems, talk about, again, efficiency algorithms. His book is wonderful, and I recommend everyone read it. Problem with it, I see, he kind of uses brute force to talk about every possible future. So if you read his book, it goes something like this. It's possible that we will have super intelligent machines or not, or we might have partially intelligent machines or have them much later. So by covering every conceivable path, he's completely right every time. But the problem is it doesn't narrow that knowledge explosion. It's interesting if you're trying to expand your mind and consider what can be, but it doesn't give you a lot of paths to get actual answers.
Yeah, I think his book is probably a lot more philosophical and intended for the general audience, whereas yours is a lot more mathematical, logical, and kind of expert oriented, if you will, where you have deep, specific, and exact kind of pathways and steps and algorithms and ideas for people who have been in the field for a number of years. It does get a lot more technical, I think. Okay, so. Tell us a little bit something. Towards the end, you have this very short but interesting touch note about the similarities between theology and superintelligence. Tell us a little bit about that.
Right. So I'm very interested in historical aspects of this type of research. So we didn't start this work last year. We keep finding papers, research papers, peer-reviewed papers going back to 80s, 70s, 60s. I think the earliest is like 1885, where people explain this exact problem. We'll have machines, will become better than us, we'll have competition. I was curious, well, how far back does it go? Typically, computer science, AI has history in philosophy, in theology, early philosophers, logic. If you look at theology, forget about religion as like, is it true, is it false, just as a study. People took a number of assumptions. There is creator, he gave us a book of instructions. From that point on, you can see it as really the struggle of creator to control creation. And all the concepts, if you give them scientific names, map on perfectly. You have this designer of biological robots who wants to give them ethical code, rules of conduct, reward and punishment. Everything maps on perfectly. And the fact that after, I don't know, 5,000 years of research, theology didn't come to a conclusion is not to a solution is not very encouraging that we're going to do it in the next 30 years. It seems like a huge problem. And what we're doing is actually harder. In theology, you have superintelligence trying to control lower intelligence. We are trying to control God. We're trying to control superintelligent being.
Mm-hmm. Very, very interesting. So, do you think that's just sort of a random stroke of luck, or just a coincidence, or is there something more into this kind of parallel between theology and artificial superintelligence? Can we read something into it, in other words?
Well, if you read Bostrom's work, he of course has the simulation argument, where we are all living in computer simulation, and more advanced users are the creators in this case. All of it is very exciting to talk about, and it's awesome, like science fiction you're reading. There is no, as far as I know, physical evidence, any other evidence to confirm any of those theories. We can generate thousands of plausible explanations. We could be in a simulation, we could be synthetic life, we could be. There is no way to narrow it down to the actual answer.
There was I think, a quantum physicist, and I'm escaping his name right now. It's escaping me, but I've sent him twice an invitation to my podcast without any reply, and he supposedly found something deep in the sort of fabric of space-time. Some of the equations that he discovered were kind of very kind of reminiscent of a simulation, supposedly. And he's an African American fellow with like a goatee beard. It's not Neil deGrasse Tyson, but it's the only other guy that I can think of. Anyway.
I know people tried experiments in physics to show that there are discontinuities or abnormalities which might indicate simulation. The whole field of digital philosophy, digital physics, is basically about that. Are we living in this computer program? And there are, again, very beautiful mappings between, what we observe and how a computer program would be. The singularity, physical singularity, is the booting process, and then we have, quantum, smallest amount of time and space. But all of it is just beautiful explanations. We cannot narrow it down to this is exactly that from inside. You never know if you are the inner simulation or a third level simulation. Just by definition, you can't tell unless you are outside of the system.
Mm-hmm, mm-hmm. Roman, let me try and nail you down here a little bit on the definition of humanity that you end up the book with. So, on page 188, you define humanity as the standard, unaltered humans. Is that a good enough definition?
It's the best I could come up with. If you allow modifications, then it very quickly becomes anything you want. It could be a software program, it could be a robot, it could be a frozen body somewhere waiting to be revived. The problem is it really makes it possible to represent as human as anything you want. You can have a printout of your software as a book. So the best I could do is kind of be very conservative and go with the current state.
Yeah, I can see that, but I want to push you a little bit on it, because I don't think it's very useful, in the sense that, is a human with a heart pacer unaltered, standard? Is a human wearing eyeglasses unaltered and standard? Are they therefore less human or non-human under your definition? Because someone with a pacemaker is definitely altered. Even with eyeglasses, I wear contacts. I'm almost blind if I don't have them. I'm definitely altered, right? So does that make me non-human?
I'm much more flexible on physical aspects. So bodies are kind of tools. I really define us as minds. And now the problem is when you change your mind by augmenting it, making it have more memory, work at faster speed, be in a different hardware. It changes you fundamentally in a sense. Well, if you're a software program, you no longer need food, clothes, temperature controls, everything. You spend 90% of your time taking care of your body. If that is taken out, really only 10% of your concerns are there. Are you still the same person? That's fundamental philosophy. What is the essence of I? What makes you continue through different substrates? I don't think I have a super intelligent answer to.
Yeah, I'm just trying to say here is that you have very specific, very kind of logical and coherent and perhaps arguable suggestions on all the previous points. And yet, when it comes to the term humanity, which is very relevant and important to the degree of the problems that we're facing, what you describe in the book, I think you're just basically ending up where most of us end up, which is to say, failing to define what humanity stands for.
I would agree. I don't think I have any solution which goes beyond 5,000 years of philosophical, theological, scientific discussion in that.
Yeah, and then exactly that's my actually the following point, which I was kind of aiming to bring us towards as a way of concluding perhaps our conversation, because you did say that it's interesting that after 5,000 years of theology, you know, God didn't find a solution for how to control his creation that works for everyone. And now we are even in the worst situation because it's reversed. We are trying to create rules and sort of ethics for God himself. Um, so, and at the end of your book, you kind of reach the conclusion, quote, long-term prospects for humanity to remain the dominant species are not great, end of quote. So tell us a little bit about that. Is that a realist?
I think so. It is based on observation of history. Look at evolutionary pattern. How many different types of human-like species we had, and all of them gave way to the better one. We always kind of progress in that regard, and here it seems the progress is just so much faster. If it used to take millions of years to get to the next level, now we're talking hundreds. In the preface to my book, I talk about my children. That's probably the only intelligent system I ever created. And one thing I observe, if they are independent of me, if they are standalone agents making their own decisions, I have zero control over them. The only way I can have full control over them, keep them safe, is if they have zero ability to be independent. So it's one or the other. You cannot have a self-aware, conscious, free-willed entity which is fully controlled by you.
I have to agree with you, of course. Um, so, Roman, unfortunately, we've been speaking for about an hour now, so we are going to have to bring our conversation to an end. Let me ask you, what's the best place for people to find more about you and your work?
My website, I hope you can include a link to that. That has everything you need, my research papers, information on what I'm working on. Um, Always feel free to email me, ask questions. I'm looking for people to collaborate with.
Okay, so let's see what's the best way to wrap up our discussion today? What's the sort of the one most important thing that you would like our audience to take away from this with you today?
So I think it's good that this topic is now becoming so popular and so many people address it. I think it's important to kind of tell who is giving you the information. So if a famous hockey player tells you how AI is going to develop in the future, it's good, but keep in mind they get hit a lot in the head with, team equipment.
So watch where you're taking your advice from.
Uh, Read a lot. Read all the books available on the topic. That's a good general strategy, and form your own opinion. Definitely bring your own ethics and your own common sense, human common sense, into this. There is a good chance at some point in the future you will have to vote on those issues as a citizen. So it's good to be informed on them.
And this is precisely where sort of the mission of my podcast and my blog and everything that I've been doing for the past 5 or 6 years stands in, because I'm trying to bring in as wider spectrum and as big of a diversity of possibilities and opinions as I possibly can. So, Dr. Roman Yampolskiy, thank you very much for being with us today.
Thank you so much for inviting me. Always a pleasure.
Singularity.